Before we get into the changes that occur between each state of matter, let's review the particle theory from episode 1. In that episode, I talked about the different arrangement of atoms, or the different arrangement of particles, within a solid, a liquid, and a gas. For a solid, the particles are tightly packed together. They have a strong attraction bond between one another. We compared the particles of a solid to being best friends. They love each other and they want to be close to one another. For liquids, the particles are loosely packed together. They leave some space between one another, and we compared them to a family reunion. Everybody knows each other, everybody likes each other, but they want to have that space. And then for gases, the gas particles are spread out. They leave lots of room between one another, and we compared the gas particles to strangers. They don't know each other, they don't want to be close to one another, they want to have their space. When we talk about the change in states of matter, we are referring to the kinetic energy of the particles. Kinetic energy is the energy a substance possesses due to its motion. The faster an object moves, the more kinetic energy it has. For example, the faster this toy car moves, the more kinetic energy it possesses. We can represent the kinetic energy of the three states of matter with this setup here, where the marbles are going to represent the particles of the matter. For a solid, because the particles are so tightly compacted together, there is only a small amount of movement or vibration. So we can say that a solid has low kinetic energy. For a liquid, we know that the particles are loosely packed together. The particles of a liquid have more motion than the particles of a solid. So we can say that a liquid has medium kinetic energy. And lastly, gas. The particles of a gas are spaced out. There's lots of room between each particle. These particles have significantly more motion than a solid or a liquid. So we can say that a gas has high kinetic energy. Solid, low kinetic energy. Liquids, medium kinetic energy. And gases, high kinetic energy. The change in the particle's kinetic energy is impacted by heat. In order to increase the kinetic energy, going from low to high, we need to add heat to the system. Heat is a form of energy. When added to a system, it increases the kinetic energy of the particles. As we increase the heat energy, the kinetic energy increases. As we increase the kinetic energy, so does the temperature. To reverse this process, if we want to go from high kinetic energy to low kinetic energy, all we have to do is just decrease or eliminate the heat energy from the system. Melting is a process where matter moves from a solid state to a liquid state. In this scenario, we added heat energy to the system and increased the kinetic energy, going from low kinetic energy to medium kinetic energy. Before, the particles were compacted together, and now they are free to move. The ice cube began as a solid and transformed into a liquid. Freezing is the reversal process, going from a liquid to a solid. In this scenario, we decrease the heat energy in the system and decrease the kinetic energy, going from medium kinetic energy to low kinetic energy. Before, the particles were free to move, and now they are compacted together, forming a solid. For evaporation and condensation, let's look at the water cycle. Heat energy from the sun is absorbed by the water, increasing the kinetic energy of the particles. As this happens, the liquid becomes a gas, and it is evaporated into the atmosphere, where it sits as water vapor. Eventually, the heat energy is decreased, and the kinetic energy of the particles decrease, and the water vapor is transformed back into a liquid. This process is called condensation, and we get rain. Evaporation is the process where matter moves from a liquid state to a gaseous state. When we add heat energy to the system, we increase the kinetic energy and we increase the motion of the particles, going from medium kinetic energy to high kinetic energy. Condensation is the reversal process, going from a gaseous state to a liquid state. For this to occur, we need to decrease the heat energy, which decreases the kinetic energy of the particles, going from high kinetic energy to medium kinetic energy. In some instances, we get a situation where gas is cooled rapidly and it skips the liquid phase and jumps straight to the solid phase. Gas to solid. We see this process through snow. As we take away the heat energy from the water vapor particles, they lose kinetic energy and they slow down, transforming into a solid, going from high kinetic energy to low kinetic energy. We call this process deposition. The reversal of this is rare, but we do see it with dry ice. Dry ice is a solid formation of carbon dioxide. When exposed to heat energy, it skips the liquid phase and jumps straight to the gas phase, going from low kinetic energy all the way to high kinetic energy. We call this process sublimation. The changes in the state of matter revolve around one thing, and that's the kinetic energy of the particles. If we increase the heat energy or increase the thermal energy of the system, the kinetic energy is going to increase. If we decrease the heat energy from the system, the kinetic energy is going to decrease.